Today we discuss what are plane curves, especially those curves which are not graphs of functions. We have several curves which are not graphs of functions, like x square plus y square is equal to s square. If you draw, you will get a circle like this, and this is not the graph of a function, because graph of a function satisfies certain conditions. It will satisfy vertical test. That means if you draw a vertical line here, it should meet only the curve at one point. For example, suppose there is a curve like this, and this is clearly graph of a function because everywhere you draw a vertical line meets the curve only at once. But here it is not like that. Therefore, this curve is not representing the graph of a function. Now, such curves are very important also. Especially imagine this is the movement of there's a path traced by a moving body. Starting from this point, suppose it moves in this direction and comes here. And suppose for a particular instant of x, where is the location of that point? It is very difficult to say. We are in a dilemma because corresponding to this point, the point may be here or here. So we are in a dilemma to locate what point we should take here. Similarly, corresponding to a point y, we are getting 2x here. So corresponding to this y, we don't know what is the location of the point. Now I will take you to a particular situations of moving of a yacht. So imagine, suppose this is a yacht moving in the sea in this path, and if it is traced, suppose in the coordinate system we are getting a curve like this, and we can see that its equation is in the Cartesian form, which is written like this: 4x raised to 4 minus 4x square plus y square is equal to 0, and it is called Lemniscate. So that's path traced by this in this situation. It is Lemniscate of Bernoulli. And what is the peculiarity of this picture? You see, can we locate? Suppose an instant some y naught corresponding to this. If you draw a vertical line, you are getting several instances of the points here. So we may not get a unique y here corresponding to an x. So we cannot find where is its location for a given y naught. Similarly, for a given x, also we are not getting a unique position here. The position may be here, the position may be here. So such a types of curves, how do we identify, especially that of a moving object, path traced by a moving object. So that is what we see here. So the drawbacks of such curves are like this. We are not in a position to express explicitly in terms of x. Even if it is explicitly written in terms of, we are not getting a unique x or y corresponding to x, we are not getting a unique y, or corresponding to y, you are not getting a unique x. And another thing is it does not satisfy vertical horizontal test. It fails, as I showed you. And indication does not tell when the body is at a given x or y. It gives no idea about the direction of it, especially when a moving body, we need a direction, what direction it moves. So that is also not obtained from the given equation 4x raised to 4 minus 4x square plus y square is equal to 0. So these are the limitations of such curves when it is written in the form f of x y is equal to 0 or y is equal to f of x. So to overcome these drawbacks, what we do is, instead of writing the curve f of x y is equal to 0, we write x and y, these variables, in terms of another variable called auxiliary variable t, which we call parameter, as x is equal to ft, y is equal to gt. And these equations ft is equal, y is equal to ft, y is equal to gt are called parametric functions, and which t is called the parameter. And of course, to get the movement, the variable t should vary some interval like this. For each t, we are getting different positions of the moving path of this moving object. And this interval where t varies is called the parameter interval. So in the parametric equation, there are things. Parametric equations are there, parameter interval is there, and the parameter is there. So writing a given function f of x y is equal to 0 or y equal to f of x in the form x is equal to ft, y is equal to gt, where t is called a parameter, are called actually the parametric equations, where t varies in the interval ab. Now this parametric equation can be imagined as actually a path traced by a moving object. It's a path of motion. So we have suppose x is equal to ft, y equal to gt, where t varies in the interval a to b. When t varies in the interval a to b, for each point in this interval, we are getting different points like this. And you trace all these points, you get a curve line. So the path traced by a moving object. So this can be considered as path traced by a moving object, starting from FAG corresponding to t equal to a, and finally going like this, and finally reach at FBGB, which is the point corresponding to B. We call this point terminal point, and this is called initial point. So the graph represented by x is equal to ft, y is equal to gt can be considered as the path traced by a moving object. And this curve, such a curve, the path traced by a moving object, we sometimes call trajectory. Trajectory is nothing but a curve traced by a moving body in a plane. Now, what is actually a plane curve? Now we are in a position to define what is a plane curve. Plane curve is nothing but a set of points in the plane. No, it should have certain properties. Points x, y, where x and y are nothing but some functions of t, like x is equal to ft, y equal to gt, which are continuous functions on the parameter interval I. So a plane curve is a set C of ordered pairs xy defined by the parameter equation x equal to ft, y equal to gt, where f and g are continuous functions defined on an interval called parameter interval. Or for each t, you get different points like so. So it can be considered as the path traced by a moving object. Now we'll go to sketching of parametric curves. How do we get the shape? How do we know the shape of a parametric curve? Suppose we are given a curve like x is equal to t square minus 4, y is equal to 2t in this. By sketching, we will know the shape of the curve. How do we sketch? What is the procedure for sketching the curve? Here, the parameter varies in the interval minus 1 to 2. As I told, when t varies in the interval minus 1 to 2, we get different points x and y, which are calculated by the formula x is equal to t square minus 4 and y is equal to 2t. So, using these equations, x is equal to t square minus 4, y is equal to 2t, you get different xy, pairs of xy for various t, and you plot all this first. The first thing is actually you have to prepare a table. That's very important. Get the pairs of xy using these formula x equal to y equal to for various t minus 1 minus 1 by t. You can take as many values of 4t also. Though the interval is minus 1 to 2, you can take more points so that you will be able to draw a very smooth curve, very approximate curve. So the more approximate curve you will get only if you take more points like this. Okay. So now getting these points, the next procedure is by selecting a suitable scale in the Cartesian coordinate system, plot the points minus 3, minus 2, minus 15, minus 1, etc. on a plane like this. Here, corresponding to minus 1, we have minus 3, minus 2. Plot the point minus 3, minus 2 here. Similarly, corresponding minus 5, 1 by 2, we have this point. Plot this. So, similarly, plot all these points. Then you freehand, you just draw a smooth curve like this. So, that represents the parametric curve represented by the equation x is equal to t square minus 4y is equal to 2t. Now, without sketching the curve, how do we know the shape of a curve? There is another method. We are familiar with the certain curves of Cartesian equations. We know what is y is equal to x square, we know x square plus y square equal to x square like that. So if you can identify by converting this to Cartesian form, we may be able to identify what type of curve is that. So for that, what you have to do is you just eliminate t and get in terms of x, the equation in terms of x and y. Here the given equations are x is equal to t square minus 4, y is equal to 2t, where t varies in the interval minus 1 to. Here, how to eliminate t? Here, from the second equation, we have t is equal to y by 2. Substitute t is equal to y by 2. Here, we get x is equal to y square by 4 minus 4. Clearly you can see that it represents, it is in the form ay square plus by plus c is equal to x is equal to ay square plus by plus c, which is nothing but a parabola. Parabola something like whose axis actually parallel to this axis, x-axis, that is x is equal to ay square plus by plus. So without sketching the curve, we can identify what is the shape of a curve by knowing the corresponding Cartesian form by eliminating the parameter t. It is a parabola whose axis is the x-axis, y equal to 0, vertex is minus 4, 0, we get. Now let us take another problem of sketching. Here the curve is given is x is equal to root t, y is equal to 2. The peculiarity of this problem is that there is no parameter interval given. Here in this case, no parameter interval is given. In such case, how do we sketch? Because we need a parameter interval, then only we can take the values of t for sketching the curve. But looking at these functions, we can identify the values of t, where it can vary. You can see that x equal to root t here. If you take negative values for t, this x is not well defined. It is not a real number. So omit the negative values here. So t can be from the interval 0 infinity. So taking this as the parameter interval, one can draw the picture by taking as many xy's corresponding to t's. As we did, first to prepare the table of values of x and y for various t in the interval like 0, 1, 2, etc. Then you can plot the curve like this. So t corresponding to c equals 0, 1, 2, 4, etc. Get the points x, y, plot the points and draw by freehand. You'll get a smooth curve like that. Now this is another problem. Here x is equal to t, y is equal to t square are the parametric equation. Here also no parameter interval is given. So how do we identify the parameter interval? You can guess it because here you see that both x and y are defined for any t, whether t is negative or positive. So you can take the interval of parameter as minus infinity. The whole r you can take as a parameter interval. So you can draw by taking the points x, y for various t. You have to take more points, then only you can identify what is the shape exactly of this curve. So don't stick on to 3 points, you take 7, 8, 9 points you take, then plotting the points you will get the shape. Now this is another type of problem here. We are going to sketch x is equal to a cos theta, y is equal to a sin theta, a greater than 0 with the parameter intervals in different ways we are taking 0 pi, 0 2 pi, 0 4 pi. Is there any difference? Let us see. Here the parametric equations are x equal to a cos theta, y is equal to a sin theta. Without going to sketch the curve, one can identify what is the shape. So let us see what is the shape of the curve. You can see that by eliminating cos theta between these two equations, we already. So it is x square by a square plus y square by a square is equal to 1, because from this we have cos theta is equal to x by a, and from this sin theta is equal to y by a, and we know sin square theta plus cos square theta is 1. So we have x square by a square plus y square by a square equal to 1. We know it is a circle centered at origin of radius a. So we identified what is the shape. But for various parameter interval, will it be circle always? Let us see. Now first let us take the case 1, case the 0 pi as the parameter interval. When theta varies from 0 to pi, starting from this point, when theta equal to 0, you are getting the first point as x is equal to, for theta is equal to 0, you are getting the point x is a cos a into 1 and 0, a0 is the point. Now take various values, pi by 3, pi by 6 like that, you take, and finally you draw the curve When theta takes the value pi, it is, you can see that it is a cos pi, it is minus 1 minus a. When theta is equal to pi, you are getting minus a 0. When theta is equal to pi by 2, you are getting actually 0 a, 0 a you are getting. So this is 0 a point, and this is the point a 0, and this is minus a 0. So you get the curve like this. It is not a circle, but it is only a semicircle. So the parametric equation, when you eliminate theta, from this you cannot say what type of the curve is. It's only a portion of the circle. So x square by a square plus y square by a square equal to 1 we got from eliminating this parametric equations, theta from the parametric equations. And one cannot say that this curve, that is the curve represented by x equal to a cos theta, y equal to a sin theta in the interval 0 pi. It is not the whole circle, it is only a semicircle. So parameter interval is also very important. Then how do we get to the whole circle? Go to the second case. When theta varies from 0 to 2 pi, you can see that when theta varies from pi, you get this, and again when theta increases to 2 pi, you get the remaining portion also. So you get the whole circle when theta varies from 0 to 2 pi. So you get a complete circle like this. When theta varies from 0 to 2 pi, you get a complete circle which is traced from A in the anti-clockwise direction. Now the third case, when theta varies from 0 to 4 pi, what happens? You can see that when theta varies from 0 to 2 pi, we found it is a complete circle. When theta varies from 0 to 2 pi, you are getting a circle. And when theta varies from 2 pi again to 2 pi to 4 pi, what happens? The point moves on the same path only. You are getting the same circle only, but it rotates again once. So x equal to cos theta, y equal to sin theta, where theta varies in the interval 0 4 pi, is a circle which is traced twice. It is traced twice. So this is the consolidation of all these three cases. When theta varies from 0 to pi, you are getting a semicircle. When theta varies from 0 to pi, you get the same whole circle of radius a. And when theta varies from 0 to 4 pi, you are getting the circle only, but actually it traces twice. And similar curve is ellipse. We are familiar with in conics that ellipse is another important curve. Let us see what is here. The curve is x is equal to 4 cos theta, y equal to 3 sin theta. Is it an ellipse? Let us see. Here the parametric intervals are x is equal to 4 cos theta, y is equal to 3 sin theta. We should eliminate theta to know what is the shape of the curve. X square by 4 square plus, that is cos square theta, sin square theta is y square divided by 3 square, that is sin square theta. Cos square theta plus sin square theta is 1. So you are getting x square by 4 square plus y square by 3 square is equal to 9, is equal to 1. Clearly this represents an ellipse. It is an ellipse centered at the origin and of semi major axis 4 and semi minor axis 3. Okay, so we come to know what is the shape. Now the problem is sketching the curve. For that you have to prepare a table of values x, y, taking theta from 0 to 2 pi. For various theta you plot all the points like this, you will get a curve like this. This is called ellipse. So an ellipse is represented by the equation x is equal to a cos theta, y in general x square by a square plus y square by b square equal to 1 is an ellipse which is represented by the parametric equation x is equal to a cos theta, y is equal to a sin theta, and also you should mention what is theta. Theta is a parameter which varies in the interval 0 to 2 pi. That is, to get the complete ellipse, theta should vary from 0 to 2 pi. Now initially we found the path traced by a moving yacht in the sea. We have actually its parametric equations now. And what is the parametric equation? X is equal to sin t, y is equal to sin 2t. If you eliminate t between these two equations, you will get the equation which started with 4x raised to 4 now. X is equal to sin t is given, y is equal to 2 sin t cos t we know. And how do we eliminate t? We have sin t is x. So this doesn't make any problem because y is equal to 2x you can write. But cos t you should write as 1 minus sine square t, so 1 minus x square. So this is the actual equation. When you squaring and writing all the terms to one side, you get the equation in the form 4x raised to 4, 4x raised to 4 minus 4x square plus y square is equal to 0. This was the equation that we discussed earlier first time, the equation represented by that curve. Now you draw the curve by taking as many values of x, y for various t. You take 0, pi by 6, pi by 4, up to 2 pi you should take. Here first I have taken only pi by 2. From theta varies from 0 to pi by 2. 0 to pi by 2. Corresponding to t is equal to 0, you are getting 0, 0. That's the point. When theta equal to pi by 6, the angle is pi by 6, you are getting this point. That is, this is the point. Theta is equal to t is equal to pi by 6. This is corresponding to t is equal to pi by 4. Like that, when t is equal to pi by 2, you are getting this point. So the curve traces like this. From this point to like this, this is the way it traces. Now what happens when theta is equal to pi by 2 to pi by 2, when this is pi by 2, actually it is here pi by 2 to pi. It goes like this, pi by 2 to pi, it goes like this, and it goes like this, it goes like this it goes. So you are getting actually it is traced like this. This goes like this and it goes like this, then it goes like this and it goes like this. So this is the way it is traced. When if you sketch it in a using a mathematical tool, actually it traces like this. It traces like this, then it traces like this it goes. So finally, actually, it is a closed curve. It moves like this. This was the path traced by that moving yachts. It's called a Lemniscate of Bernoulli. This curve is called a Lemniscate of Bernoulli. Now, another curve is very important curve in the parametric section is cycloid. What is cycloid? Imagine a wheel or a circle with a fixed point marked on it, moving, not actually moving, it is rolling on the line, on the line, without actually slipping. Should not move to the right side, but it should roll. When it rolls on this line, the path traced by the moving of the fixed point so the path traced by a fixed point on the circle when it rolls on the line is called a cycloid. So this is the blue line, that is the path traced by this fixed point. When it rolls on this line, you will get the path like this. When it rotates completely once, you will get one arch of the cycloid like this. And when it again rotates, another arch. So several arches are obtained by rotating this wheel on this line. So this is what is called a cycloid. Now we are going to find the equation to the cycloid. Now imagine a particular instance of theta when it rotates an angle theta. Suppose this is the position of that fixed point starting from this point. So this was initially the circle was like this. The circle was like this. Actually, this was the position of the circle. This was the position of the circle here. This is the point. When it rolls, suppose this point reaches here. This reaches here. Okay. Now from here, when it rotates theta, there forms actually a right angular triangle with the angle theta. Sorry, right angular triangle with this angle theta, and the arc PM, the length PM, is nothing but the distance OM. So that is the peculiarity of this movement. The length OM is nothing but the arc length PM. Now we are going to find the position x and y in terms of theta. That is a parametric equations. So let x p x y be any the position of the point. That is the coordinate. This is x. This distance is x, and this distance is y. Suppose. Now what is x actually? From this figure, and let this be point some n here, this point. Then x you can write as OM minus Mn. OM minus Mn. And OM is the arc length Pm. Arc length Pm minus Mn. And what is Pm? That's arc length. Arc length, we know the angle is theta, central angle is theta. So arc length is nothing but A theta. See, if you take A as the radius. So this is A theta minus. Now what is Mn? Mn is this distance, and Mn is the same as this one. So I am marking L here. It is PL. From this right angle triangle, PL divided by A is sine theta. Therefore, this PL is A sine theta, and similarly CL is A cos theta. So here we want PL because we want to write Mn. So this is A sine theta. So Mn is A sine theta, which you can write as A into theta minus sine theta. Similarly, what is Y? Y means the Y coordinate of this height, and this height you can same as Lm. That is Lm, and Lm you can write as Cm minus Cm minus Cl, Cm minus Cl. Cm is nothing but the radius of the circle, which is A minus Cl. Cl is from the right angle triangle, it is A cos theta. We are getting A minus A cos theta is A into 1 minus cos theta. And therefore, the parametric equations of this cycloid, that is this x and y, you can write in terms of the parameter theta as x is equal to A into theta minus sine theta, y is equal to A into 1 minus cos theta. So x equal to A into theta minus sine theta, y is equal to A into 1 minus cos theta represent the parametric equation of the cycloid. With this, actually, I stop this session and we'll be seeing in another session later. Thank you. Thank you very much.